Hey friends, welcome to this lecture Data Management. If you are new to this course, my name is Enoch. I'm a research assistant at the Department of Medical Epidemiology and Biostatistics at Karolinska Institutet. In this lecture, I want to show you how to do data management in an entry-level way. I learned data management from Anna Johansson's workshop at KI Library, the link of which can be found below, and also the MAP guidelines for documentation and archiving. First is the outline for today. I will start from telling you that what if you don't do data management, and then the aim of doing this, continue with a couple of good things that you should know. For example, folder structure, documentation, README, and some good habits on coding as well. So first, it is quite often to see that your desktop is super clean in the beginning of your research. Whereas on the halfway of research, it sort of starts to look a bit like a mess. And even at the end, you realize that, oh my god, that is a mess. And imagine now, if you want to correct your table 1, where is the do file for descriptive analysis? How can you find it? You have to ask yourself. Second, if your supervisor says, please summarize how far you've already gone in this project, you probably cannot just drop him your syntax and say, yeah, that's what I'm doing and what I have already completed yet. That is absolutely not the way we prefer to work with our supervisors. And how about if your classmate asks you to teach her how to write a certain Stata code? Can you really remember where you put your file? And you found out, alright, you cannot really find it. And what if your collaborator needs to take over your analysis? Can he understand what you've already completed? It is actually quite often to have someone else to understand your analysis as well. Well, and if your data management looks like this, I would totally say that you really screw yourself up. And that's why I recommend you to do data management at the very beginning of your project. The aims of data management are to ensure the analysis is reproducible, because you probably need to redo the analysis numerous times during the entire project, and also to work coherently and efficiently with yourself as well. You would also want to ensure the project can be understood by others, not only now, but also in the future that you might need it again. You also want to create a good workflow and enhance accuracy of work. You can always go back to check what you've done. I cannot emphasize how important it is. So, this is a basic structure of a project folder. Let us start from the folders. You have data, you have documents, log, output, and program. The data folder is where you store your data sets. The document folder is where you put some files like ICD code reference, some useful guidelines relevant to the project, and for example, for your own timetable for this project. Log is for logs files, which are the records from software. Output is the folder for the graphs and tables, which are usually generated from the statistical software. Program folder is for the syntaxes, the codes of the statistical software. Okay, great. And besides folders, you would also have some documents for your project. First, analysis plan. It is more than just merely your proposal, but how you're gonna conduct the analysis part, from data clearance to statistical part. Codebook. A codebook should illustrate what are the variables in the data sets, the names of the variables, the types of them, they are numeric, or they are factor, or they are character. If you are using more than one dataset, you need codebooks for each and every single dataset. Dummy table goes for empty tables and graphs. You first create a table, name the rows and columns. Or for graphs, you can give the x-axis and y-axis first. Dummy table sort of like, I would say they play like a role, like a blueprint in this project. You sort of need a map to know where to go, and dummy table is definitely your good friend. Logbook is like the working diary. You will record what you do every time. It probably takes only 2 minutes to record what you've done in that day, so remember to do that. It's just a habit. But this is a good habit for helping yourself and others to know where you are in this project. Manuscript is where you can write the results of the analysis. Some people put the background part, the method part, and discussion part inside as well. And I would say, well, it really depends on you. And finally, you need a readme.txt file. So you or other people can know how to use the documents and folders in this project folder. And what are they? It is sort of like a tour guide to know like the entire project folder. The next part I'm gonna talk about is some good habits you can have for your coding. First, you have logon. You set up a log file. So you would tell Stata logon. Then, give the file name of the codes, the title of the study, when this study was created and updated. I mean the file itself, when was it created and updated. The purpose of this file, some notes and comments that you want to put it as reminders as well. Then it would go into the program. For example, you say use what kind of data set and start to do the statistics part of it. Then you log close and end the records. Here are some other good habits I would also recommend you to do is like you can talk to yourself as much as possible and write those like comments and notes into your syntax. Those comments you write would pretty much help you to understand each step. And the next one I would recommend you got a friend in me. There's a song in Toy Story. And then I highly recommend you to do that if you have friends. Also really into like doing the same analysis that you are doing. Do it, please. Do a parallel analysis and check the results together. Both of you will learn from each other quite a lot. I was actually benefited from it a lot. I have some friends, they are doing that with me, and I'm happy that we can learn and grow together. So I recommend it. And then there's a term called like rubber duck debugging. It's like putting a rubber duck in front of your laptop, and you always have to make sure that the rubber duck understands your analysis. So it should be simple. It should be a more understandable language to know what you are doing in your syntax, your code. So talk to it. It may sound a bit like stupid, whereas it is just to imagine that you are talking to someone. And the rubber duck is always a good listener, isn't it? Here are some other do's and don'ts. I would say first, use a shared folder project server. Sometimes that you are even required to do that because of data privacy. You are only allowed to keep the data at a certain drive. Let me tell you a story. I have a friend who always store all her files on her laptop only, and one day, it was during our thesis period, her laptop was stolen. That was horrible. So trust me, always have a copy for your files. So using a shared drive could be one of the solutions. Give appropriate names to your files and variables. First, no stupid names such as like new 123, final 123. I would say like you use a date instead. And then no space, no special characters, no dots as well, just in case the software cannot read it. And for binomial variables, 1 implies yes and 0 implies no. For example, if that person is female, 1 means that person is female, 0 means male. Next one is label your variables, please. So you would know the meaning of those variables. And for how to label a variable, I'm gonna talk about it later in our lecture later. And also for using the same names for linking files. For example, if you have do file, r file, source file, the log, and if you export something in Word, you can use the exact same name, so you would know that these files, they are linked together. And don't replace the original files or variables. Create new data sets or variables instead. Just don't replace it, because sometimes you need to go back to check it and you cannot find the original data sets or variables. And also, don't edit the data directly. Please write syntax so you will know which part was changed and how you change it. This is to prevent your dataset from being contaminated. Write some syntax, please. Alright, we need to wrap it up. To have good data management for your project, you need to have good folder structures, documentations, README, and good habits on coding as well. You might feel not super benefited from the lecture as you are listening to me talking about all the stuff here, but I hope one day if you just begin planning your project, all the templates and the contents of this lecture can give you a hand on it. These resources can be found below as well. Goodbye. Hej då!